Hi, everybody. My name is Cassandra Rosette, and today I will be discussing the Meuse Valley Fog that took place in December of 1930. The objective of this presentation is to understand the causes of the Meuse Valley Fog, discuss the sources of pollution that led to the fog, understand how weather conditions played a role in the fog, and examine the symptoms experienced by those trapped during this time. Here you see the table of contents, which states the topics we will be discussing today. We'll move right into the fog disaster of 1930, which provides a map of this area. Map of Meuse Valley, Belgium. In 1930, this 20-kilometer stretch housed close to 27 factories. These factories included explosive plants, glass and steel manufacturers, and zinc smelters, along with many more. If you look at the image, the pink-purple color on the image represents the densely populated area. So this area was not only densely populated with factories, but also families and individuals. Periods of persistent fog were uncommon in the Meuse Valley region, with only 5 events of fog greater than 3 days ever being documented before. However, the 1930 Meuse Valley Fog was documented as the worst fog to take place in this region due to the illness and death rate. If you look at the table here, you can see the years that the previous fogs took place. So we see 1901, 1911, 1917, 1919, and 1930. A fog greater than 3 days was documented during these years. The conditions. So the weather conditions created an unusual pattern called a temperature inversion. So air above the surface remained warmer, prohibiting colder air from rising. Therefore, the temperatures mixed, creating a temperature inversion. So if the air mass sinks low enough, the air at higher altitudes becomes warmer than the air at lower altitudes, producing a temperature inversion. If you look at the line graph here, we see that as the altitude decreased, the temperature increased in normal conditions. However, with a temperature inversion, this is not the case. Sulfur dioxide in the air. So sulfur dioxide was found to be the main cause of illness due to the fog. So the max during this time was 25,400 micrograms, and the EU alert threshold for sulfur dioxide is 500 micrograms for 3 consecutive hours. So there you see a significant difference between the alert versus what was experienced in this area. The annual concentration in this area ranged from about 20 micrograms to 60 micrograms, with daily means seldom higher than 125 micrograms. So looking at the bar graph, you see maybe a slight difference between the average sulfur dioxide levels versus what would be alerted by the EU. However, to graph the max during the Meuse Valley Fog would be quite difficult due to the significant difference between the alert threshold and what was experienced, along with the average in this area versus what was experienced during the Meuse Valley Fog. Symptoms. On the 3rd day, the fog reached maximum opacity, and the first symptoms arose simultaneously in people throughout the valley. So the common symptoms included coughing fits, laryngeal irritation, and slow breathing. More severe symptoms included cyanosis, frothy sputum, and pulmonary edema. After the fog cleared, most of these symptoms improved rapidly in individuals. If you look at the pie graph here, you see that majority of the people experiencing symptoms experienced minor to moderate symptoms. However, 25% of the population did experience the cyanosis, frothy sputum, and pulmonary edema. Approximately 60 deaths were reported, which accounts for 1% of the population in this area. An overview. So between December 1st and December 5th in 1930, a thick fog covered a large part of Belgium. This atmospheric pollution led to a fog that caused many individuals living in the area to experience respiratory signs and symptoms, and even death. The Meuse Valley Fog was due to the area being densely populated with factories in combination with climatic conditions, which refers to the temperature inversion trapping the air. Currently, the Meuse Valley is a river park with a synergy between landscape and nature and recreation and tourism. Thank you all for listening.